myself Drashti Parikh, and today I'll walk you through the assignment 2 of my Python. So in this assignment we started with first of all mounting the .csv file using the Google Drive. So from Google Colab we'll try to import the drive, as you can see has already been mounted. So next I'll give a variable file name, the address of my CSV file from the Google Drive, and by importing pandas.as pd I'll give the name Iris to read my content of .csv file. Just to confirm, I'll try to print the first 5 rows of the .csv file. As you can see here, the first 5 rows has been printed. In question 2, it's telling me to convert the last column strings to integers. So here I'll have already converted the string name Sentosa as 0, versicolor as 1, and then Virginica as 2. Next up, I'll try to map the variables, the string to integers. So it has already been converted. As you can see here in the column, it's 0, 1, 2. It's already converted into integers. In question 2, it's just for verifying. We'll try to print the first 5 columns of Iris data set once again. So yeah, next up, in question 3, it's telling us from the data frame, give the first 4 columns to x and the last column to y. So using the iloc function, we'll try to give the first 4 columns to variable x and last column to variable y. So just to confirm, we'll try to print, as you can see here, the first 4 columns has been named as x.head, and it's printing the first 4 columns, and the y.head is printing the last column. Now in question 4, it's telling us to split the data x and label y into training and testing segments and call them as xtrain, xtest, ytrain, and ytest. So we'll try to import the train test split library. Next up, we'll define all of the xtrain, xtest, and ytrain and ytest variables over here, and we'll try to print the first 5 rows of xtrain, xtest, ytrain, and ytest over here. And then in question 4c, it's telling us to check the length. So the length of xtrain, as you can see here, it's 120, and the length of xtest is 30. In question 5, it's telling us to convert ytrain and ytest from categorical to one hot-coded encoded values and call them as the following respectively. So we'll try to import the required libraries, and as you can see here, we have named the ytrain and ytest to the categorical, and then we have named it one hot train labels and test labels. And we've tried to print the first 5 rows. As you can see here, it has already printed the first 5 rows of xtrain and xtest and renamed it accordingly. Next up, question 6. In question 6, they're telling us to define a sequential model that has 3 dense layers. So the first layer has 100, and the second also has 100 neurons, and their activation function is ReLU, and the third output layer has 3 neurons, and the activation mode is like softmax. Next up, we'll try to compile the model. The optimizer that we have used right now is RMSprop. We can change it later to anyone according to our need, and that's all. We'll try to print the model summary. This is the model summary. Right now it has 3 layers, 2 hidden and 1 output layer. So next up, we'll compile it. So it has compiled here. We have compiled it before. I just have written it here again. Next up is like training your model. It has first told us to use the Epoch S20 and batch 10. So as you know, the lower batches have higher frequency, higher accuracy. So right now we've given the Epoch S20, so it has 20 of reports. Next up in question 8, it's telling us to calculate the result and evaluate the xtrain and one hot test label. So we'll try to run it. As you can see here, right now our test accuracy is 0.9667. In question 9, it's telling us to repeat all the things that we have done in question 6a, and just to change the hidden layers from 100 units to 10 units, as you can see here, and activation is same. And for the output, we need to use the 3 hidden units, but it's already was 3, so we just change from 100 to 10 in here. Activation is same. So first one is with 10 units, second is with 10 units, and the third one, output layer, is with 3 units. And same thing, we've compiled and we have printed the summary. As you can see here, the output shape, it says 10 hidden units, and then the third one for the output layer, 3 for the output layer. Next up in question 9b, it's telling us to compile with optimizer. Same optimizer. So as you can see, we have used the RMSprop. So same thing, we'll use RMSprop in here. And yeah, that's all. We'll train the model with batch size 10 and Epoch 4 as told. So yeah, that's all. And then we'll test the accuracy. So as you can see, it has only the accuracy of 0.433, which is much less than compared to the one with the 6th question. So next up, in question 10, they are telling us how the questions like how the number of layers or hidden units could impact the accuracy of our model. So more layers and hidden units can capture more complex patterns, potentially increasing accuracy. So there's often a sweet spot that balances model complexity with generalization ability. So next up is like, do we suffer from overfitting? So we don't usually suffer from overfitting. Overfitting occurs when the model learns the training too well, like including the noise as well, which is the like unrequired data. It's more common with complex models and small data set. How can we detect overfitting? Comparing training and validation accuracy or loss. If training accuracy continues to improve while validation accuracy decreases, it's likely overfitting. And how can we reduce overfitting? We can use regularization techniques, L1, L2, or dropout. We can increase the data, which is the training data. We can reduce the complexity, and we can early stop it, or we can use data augmentation for appropriate data sets. Next up, they're telling us to change the parameters and see what happens. So the first thing they're telling us to change is the optimizer. So right now the optimizer which we are using is RMSProp. So we'll go back to question 6a. So as you can see here, the optimizer we are using is RMSProp. So I'll try to change it to let's say Adam, and let's see what happens. So different optimizer can affect learning speed and final performance. So optimizers like Adam or RMSProp make coverage faster or find better minima than the simpler optimizer like SGD. So next up, they are telling us is to change the hidden units. So over here right now it's 100 and 100. So what it's saying, we'll just confirm. So yeah, it's telling us to change the number of layers. So we'll go back to question 6. So right now it's 3 layers. Let me try adding one more. Let's say dense. So we'll just close this and add and I'll make it 1, or let's say 10, and same as the one above. Relu. I'll just try to run it. So as you can see here, it has added the fourth dense layer with 10 hidden units. So next up, it's telling us to change the hidden units. So as you can see here, right now it's 100 units. I'll try to take it to 10, and also this one is 10. So I'll just try to run it. So as you can see here, the output shape has been changed, and it will also affect the accuracy. So after I run the test accuracy, oh yeah, it's the same thing. Next up, they're telling us to change is the number of epoch. Okay, so let me just go back in here to the 6th question. Yeah, over here right now it's 10. I'll take it to 10, and you can see here it will now only read the 10 times. So more epoch generally improve performance up to a point, after which overfitting may occur. So longer training allows the model to learn more from the data, but eventually it may start fitting to noise. And the last one is the batch size. So over here right now our batch size is 10. I'll make it 20 and I'll run it. So yeah, larger batch size can lead to faster training, but it may result in lower accuracy and overfitting. Smaller batch sizes can provide more accuracy but are computationally expensive. So larger batches provide a better estimate of true gradient and leading to more stable converge. Smaller batches introduce more noise, which may help to escape local minima, but may also slow down the coverage. So that was all from my side. That was my code and explanation. Thank you so much.